How's it going, everyone? Eulier Gonzalez here, and today take a look at the front-end system design, which is the natural step, especially when you're starting to look at how you can write applications in JavaScript in the web using the HTML, CSS, and JavaScript, and then now how you go through JavaScript as a way to understand is the primitive, the data structures, the conditions, the for loops, control flow, and variables, as well as functions, and how all of these concepts actually fit in the entire browser. Concepts like function execution context, lexical environments, and then uh, take a look at the async nature of JavaScript as a way to understand now how JavaScript, because at the end of the day, this is a one thread, it's a single thread language, which means that it's going to evaluate your statement line by line, and how can we make now this language to support these async operations or tasks that will take some time to complete in the future. So by looking is now at the callback queue and the timers, as well as the environments that JavaScript can run, whether it's the browser and the server, and basically looking at the browser as well as the API that allow us is to perform this async operations using promise, which is a built-in objects, and how now this promise actually has its own mechanism to deal with this async uh, nature, this async task by using is a queue, aka the micro task queue or the job queue. So when we look at all of this, and as we move on how can we now understand and make sense of things like async and await as a way to make the asynchronous nature to look like synchronous, because at the end of the day, JavaScript is a single thread language. We want to make or give the illusion that when we're writing is JavaScript code asynchronous statements, we want to do that in one line, and what is using behind the scenes to allow this. So for example, like iterators and generators. And when it comes to look at how can we organize our applications, data and its functionality, the reason of why we use object-oriented programming in JavaScript, and how can we now is using is this object-oriented prototype nature, which is the way of how can we now is extend property and method, or technically speaking is access to property and method from other objects. Okay, so by using is now the object.assign, object.create as a way to create that reference, understand the reason of why we use that, as well as the why we use the new keyword and what is the benefit of using that, what is doing behind the scenes. And now this recently, not that recent, feature of class that is just mimicking the behavior of object-oriented programming in JavaScript, but behind the scene is using is the prototype nature. This is just to look like this is just to make the language to look like object-oriented programming, like Python or Ruby, all right. But behind the scene is using is uh, the prototype nature, this way of how you can have access to other property and method, and how it's important to also follow is the solid principles. Single responsibility, open to extension, close to modification, the least substitution, the interface segregation, as well as the dependency inversion. And how all of this When you combine that to now create is React application or user interface using React, how all of this makes sense is a way to understand how all of this particular flow works together. So once you know the language, how you can write application in there, what is the inner mechanism in the language, as well as how all of this library or frameworks allow us is to build is now user interface, then the natural step is to see how can we now design is, or at least have a mental model of how can we design how can we design or understand the fundamentals of system design, because as we look at the core nature or the core features, then all of this how it's going to build up to actually form our knowledge to reach to this point is like how can we actually make sense all of these low level features as a way to now build more scalable user interface web applications, right? So that's the entire goal of today's video, and I think this is quite interesting. Well, not today's video, the end goal of this course, and I think this is quite interesting. Is describing the entire story of where do we where where do we come, why we are here, and how do we get here. So the entire reason of looking at this course from Yevgeny, I think is I pronounced that right, Yevgeny, right? The software engineering, which is now a UI engineering, and it's interesting because a lot of company actually are looking for this staff UI engineering, which is hey, I need you to not only be someone that can provide is value to the business but also to the team. And well, he identified a particular issue, which is a lot of these UI specialists and especially front-end engineers must know the fundamental of system designs when it comes to build large scale applications. So for that, it is important to see first how the browser renders, how the browser works, at least right now, because there is a lot of things that has been updated over the past 10 years. Okay, so how the browser works, DOM APIs, the Observer API, how to build a virtual list, application state patterns, network patterns, mocking systems to build a social media newsfeed. But the idea here, okay, of all of this, is that this is just also to describe is what are the skills that company are looking for. So the analytic skills, the technical communications. Hey, can I implement your approach based on your explanations, as well as the engineering best practice, soft skills, and language and computer science experience as well. And how? By looking at this particular core structure, the introduction, the core fundamental, which is what we're gonna focus in today's video, is to see how all of these building blocks stack each other as a way to now understand how can we build this now web apps in a scalable way. So, because the idea of this course, according to Yevgeny, is to understand how all the library patterns that UI specialists use for the daily jobs or to provide to or to provide for our clients for an interviews, okay, is to understand the patterns of all of these UI libraries, use as well as their API to gain more perspective about it. The TLDR is to understand how all of these library patterns are using behind the scenes as a way to make ourselves familiar with, and then when it comes to need to implement something like that, uh, we don't need to do that by the scratch, but we understand what is happening behind the scenes. So the TLDR is that know your stuff. So because here the front end, after all, is it was particularly the front end design system. In any applications, you have several layers. You have now the backend, you have the API, and the front end. I start with the front end. So in the front end, you can. So the front end is all about is the data. How do we communicate to the server or to the API? How now we fetch that data and manage that in our application. How can we implement now some user interactions and complex user interaction with this data, and then find a way to manage all of your assets by splitting multiple chunks and load them as needed, load them as on demand. So you can now keep a healthy Web Vital metrics for that. And this four particular concepts is actually pretty straightforward, you know, about what we are going to do or what front end design is all about. Especially when you're going to define is now these applications, right? In React or in any other applications. The front end on the web primarily is that. What is the data that I need to? What is the data? How can I communicate to the server? Okay. Is that how can I communicate with the server as well? Is that how can I communicate with the server? How can I load and manage that information in the front end and provide some new user interactions and complex in how to handle complex user interactions in a way that is, for example, hey, how can I now is fit all of this data that I get in this small screen? And then the asset management is like, how can I make all of this data that the server is sending through the client, process them on demand, so we can now actually provide a smooth user experience. So all of this is now, this is the course plan to actually take a look at this. Let me actually zoom in here. Zoom in, that's right. Okay. Because this course plan is actually pretty descriptive. It's going to make sense of how all of these things actually fit together. And specifically the core fundamentals here. So far we have looked at the box model, the positioning, the system design, and that kind of thing. But in each one of those topics, all right, here we're going to look at how now JavaScript or how now the browser treat HTML. What is the how stacking context is connected to formatting context. Something that this is the first time or the second time I hear about formatting context, how such contexts are connected to GPU, the browser rendering cycles, and the composition layer, and how we can use the GPU to optimize the rendering. But as we can see, how all of this specific knowledge is going to then to look now at the DOM API, a refresher of the DOM API, which is after all, this is like a shovel when you're trying to find that element here. Some of the web API used in most common and complex UI patterns. So for example, like the observer API, mutation observer, resize observer. But it's interesting because all of them use is the observer API, and this observer is just the observer Okay, the observer pattern, which is this. The observer pattern is anytime you want to look a particular event, anytime you want to look at subject, and you want to get is the data. Okay, so anytime you see a particular yeah, anytime you see a particular subject, and you want to know news about it, this is the observer pattern, or this event subscriber listener. A real life example of this is like there is a celebrity, perhaps Messi. You want to know more about what he's doing, if he went to the bathroom, how many times he did that. You shouldn't do that. Leave that as leave that man alone, please. Do something else with your life. But in any case, you want to know more about what he is doing. So this is now the pattern of the observer subscription or event subscriber listener. So now you subscribe to that event, let's say to that Instagram account, so you can get actually updates from that. This is not only, for example, for celebrities. This is also interesting because this behavioral pattern is also uh, pretty much from like anything that you are interested in, right? So the news, the economy, something related to your profession, whether it is the medical informatics or engineering, communications, social science, hard science, any specific thing that you care about, that you're interested, or even on entertainment, anything that is that, all right, how that thing is, how you can subscribe to that as a way to get some updates. This is something much more critical in today's world, because now we have is the decision making is crucial here, as a way to identify is what are the source that you want to subscribe, what are the celebrity or the subjects or the magazine that you want to subscribe, and what is the value that you are getting from this. So, yep, 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 totally. So, in any case, but it's that is using is the observer API. My question is that since I have used this in intersection observer, but not the mutation or the resize, both of them are using is now the observer API, which is what is doing this behavioral design pattern behind Java's behind the node, as a way to now detect all of these events when they happen. We also look at the virtualization. How can we going to build this now this virtualization in our application, as well as the application state design, like search or access, browser storage API, local storage, for example, memory offloading, as well as the network. How can we communicate to that? What are the protocols that we can use? And to me, that's quite interesting about this protocol SSE, um, streaming. Okay. Mm-hmm. Server send events. Mm-hmm. Mm-hmm. Enviando eventos del servidor. event source. Mm-hmm. Server sent event. Mm-hmm. Server sent event. Okay. Mm-hmm. That's quite interesting. I never heard about that, and that's the reason why I'm actually paying for this. All right. So, because of this, long polling, WebSocket, SSE, REST, and GraphQL. Okay. Because of this, then we're going to look at with this web application performance as a way to see how you can now organize or manage your assets on demand. But so far we have looked at the core fundamentals. Okay, it's like how the browser treats the HTML, the position system, the formatting context, the stacking context, okay, browser rendering cycle and reflow, composition layer, and GPU acceleration. But how now the stacking context is connecting to the formatting context, and we are now know what is the formatting context is after all, and how such contexts, the stacking contexts, are connected to the GPU, the browser rendering cycle, and the composition layer, and how can we use the GPU to optimize the rendering. This will be a very interesting video of today. Yesterday we talked about is the box anatomy, where you have now, or at least the core concepts. When first we take a look at the box model, okay. This is actually is part of the core concept when it comes to design front-end systems, okay, especially on the web, because if you're going to design other systems, it's gonna vary. For example, if you're going to design front-end applications for a particular device that is not the browser, okay, let's say the mobile, that's quite different. But as long as there is a browser involved, yes. Okay. So this is the core concept. Box model, where everything in CSS is treated as a box. We look now at the box anatomy, which is, and I really like to actually bring that CSX box here. Exactly, the box model. This is part of the building blocks of CSS. All right, the box model. Yes, the box model. NBN resource. Okay, that's right. So this is now the box model. In CSS we have several types of boxes, okay, and everything in CSS has our box around, and understanding these boxes is able to now build more complex layout in CSS. Not only layouts, but also combine that with UI patterns or complex UI patterns. So so yeah, this is the box model. Everything in CSS is around a box. So if you understand how that, so understanding this box is key for create more complex layouts and see how to align items next to each other. So we look at the anatomy of a box, which is made of the content, the padding, the border, and the margin, right? And also a specific code pen here, which is a code here that is now taking in consideration that one. That's interesting. So I think the using is jQuery or not. Oh, document query selector. Okay. So here we got is our HTML here is gonna put is an ID, right? And any time we actually field set of controls, okay, so border, margin, padding, and content, we are now drawing is the container, and inside of this is the box. So we can see is actually now how that changed. That's quite interesting because it's not showing that as expected. Okay, there you go. Oh, it's only showing is okay. Anyway, but the idea here is that we are now capable to represent that. So when that value change, so when we detect a value that change here, okay, hey, is now the field set input. Whenever it change, okay, so for all of these elements that match the field's input, when they change, I want you to now is update this function called setBox, which is this. You're gonna pass the target value, you're gonna pass the name, and here you're making is a switch case for this, right? So if this is the box sizing, you're gonna update now the box, which is actually take a look at that content. Okay, take a look at that document, get that document, and then updating it is proper properties, right? So first is with the box sizing, the other is with the padding here as well. The other is with the margin, adding some margin to that. So for example, when we play with the margin here, it's actually playing with the margin properly. Okay, if we add 10, you can see if we add 100, let's add that. If we add nothing, it's not. Those kind of animation are handled by the browser. We don't have control about that. Followed by the margin, border, and the content. Where now the content here, we specify the content at 30. We can put that 25 or 0. Okay, so this is not to represent is the content. But as you can see, wait. But as you can see, remember that after all, here, the content is representing in here, like this. Padding is representing, yeah, wait, this is, but this is border box. Okay, exactly. If we take a look at this, all right. So now this is the content. Actually, that's pretty straightforward. So this is the content. Okay, the content is 60 pixel or 100. Now that makes sense, right? Or it can be is 400. You know, like so. And this is quite interesting because the browser is trying to align that all of the elements inside of that box because it can. So they must define something when that happens. For example, on the box, they must define is a control. Okay, they define as a control like that. Which means that they are creating is a different browser formatting context. Here they're creating is a different formatting context and how that is connecting to the stacking layer. Okay, why we are actually take a look at this, because from this simple example of the content, what? God damn. Because from this simple example of the content, right, where in there we can see how now the content is added to that, okay, the width and the height, and followed by the border, which is now something that we don't actually showing here. I think it's this is 30, this border. But first we're gonna show is now the padding, which is on green, followed by the border, which is in red, and then the margin, which is in orange, right? But the whole point of this is to identify is now the box anatomy, the content, the padding, the border, and the margin. So far so good. And how you can now actually is apply something to this. So here what they're doing is adding that whatever input they define, they're gonna add this change event, and they're gonna run is this, right? So they're gonna pass is now the target that input to the change as an object. What they're gonna have is the value as well as the style. No, this isn't change. Exactly. The target and the style. Okay. So, this is it. It's pretty straightforward. Then we also look at that this box anatomy has properties. So the properties of this box, like this property of this box can be either box size or box type. And the box size is containing in itself is intrinsic and restricted. So this box size, which is something they define here, I think it is box size. Let's say box size. Content box size, border box size. Oh, resize observer entry. Okay, that's right. Well, in any case, we got now the two type of boxes, which is something that they don't even talk about that. Well, but we got two sides of boxes. Okay, we got intrinsic and restricted. So the box size can be either intrinsic or restricted. Again, talking about its size, and it is intrinsic when the content is determined by the space it occupies, the width and the height. All right, or it can be is restrict based on the width and height that you provide via CSS, or they constrained by the parent or other boxes mechanism like flex or grid the layout system, the percentage of the parent size, the aspect ratio property on image interest. So the aspect ratio is property of the image and the presence of other children in the DOM. Okay, and it is there other children's in the DOM. Again, this is one type of box, right? Or property of the box. So you have box size, how the browser is going to determine the dimension of this box, as well as the box type, that it can be either is or a block level, or an inline level, or an anonymous element. I don't use anonymous level or anonymous elements, but this is the way how now the browser determines when the content is not wrapped inside of a particular HTML element. So the block element is included but not restricted by display block, the inline level, and the anonymous box. So the box type block, the element is rendered like a block, and you have all of these elements here, and you got all of these elements that allow you to do. Okay. So for example, mhm. So for example, here in the box type block, since all of these things, the way now how the browser determine is not only the size but also what type of block it is, and based on the type of block, how it's going to behave respects to itself and other blocks, as well as the children blocks, okay, or as well as the children elements. So the type block, it takes in the block elements, it takes 100% of the pattern containers width. It takes 100% of the pattern container width, and the height is determined by its intrinsic value, the height of the content. And the element is rendered from top to bottom, and it participates in something called the block context formatting. Again, something that we're gonna see that later. First time I heard about this, and that actually exists. Is that block blocks formatting context. This is quite interesting. A block formatting content is created by at least one of the following: the root elements of the document, floats, absolute position elements, inline block, table cells, table captions, anonymous table cells implicit created by the elements with display table, block elements where overflow has a value other than visible and clipped, element with display flow root. What in the F is this? Flow root. Flow root. Flow root. Oh my god, this is the first time that I hear about this. Flow root. Holy moly. This is the inside values. Flow, alright. Flow root, table, flex, grid, and Ruby. Elements behave like an inline level elements and layout it is counting according to the Ruby formatting model. Ruby formatting model. What in the F is this? The Ruby annotation element representing small annotations that are rendered above, or next to the base text, usually used for showing the pronunciation of East Asian character. Oh my god. That's the reason why I never use this. That's the reason why I never use this. Because this is now how you tell Western people, hey, this is how you pronounce this. It can also be used for annotation other kind of text, but this usage is less common. The term Ruby originated as a unit of measure used by typesetters, representing the smallest size that the text can be printed on newsprint while remaining legible. Ruby. Holy moly, bro. you oh sh. The Ruby text container element. This is deprecated. The Ruby text container. Oh my god. The Ruby base element. The Ruby fallback parenthesis. Of course, because the entire and a lot of people are actually providing solution is to rich people, to wealthy. To the wealthy, bro. Jesus. I didn't know that there was a. Oh my god. Alright, so, okay, so with the Ruby and grid and flex and all of this, um, yeah, that's what it is. That's exactly what it is. Holy moly! Anyway, anyway, this is just describing is the block formatting context. Elements, buttons, elements contain layout, flex items, direct children of the element with display flex or inline flex if they are neither flex nor a grid nor a table container themselves. Of course. Okay. If the direct children of the element doesn't with display flex or inline flex, grid elements, the direct children of the elements of the displayed grid, if they are neither flex nor grid nor table, multi-containers and that kind of thing. This is something interesting. This is block formatting context using overflow auto, display flow root, and HTML. I'm a floater box. I'm a content inside the container. I'm a floater box. I'm a content inside of the overflow auto container. I'm a floater box. I'm a content inside the display flow root content. Exclude external floats. Recite this outer float. Try to recite this outer float. Prevent margin collapsing. Preventing margin collapsing. Margin collapsing example. And background transparent. Well, in any case, okay, okay. So, Jesus, okay. So as we, all right. So as we move on here with this specific example of the box anatomy, which is the content padding, border, and margin, and how now the browser uh, define this or label this box into size as a way to determine the dimension and the type of block. Okay, so for the size, you have now intrinsic and extrinsic, where the first is how this is going to be calculated, how the size of this box will be calculated, intrinsic, which is based on the content itself, right? And width and height are determined by the space that that content occupies. And then you have the restricted. And here is, this indicates now the size rule, or the restricting is a set of rules that you apply to this box that is either width and height via the CSS, or it is pattern elements or it is padding elements constraint mechanism that it can be, whether it's the percentage of the padding elements or the flex and grid, or the aspect ratio of an image, interesting, or the presence of other children in the DOM tree. So this particular element contains other elements or sibling elements here, or or children elements. The presence of other children elements in the DOM. So because once we look at the box size and the box types, which is inline, block, and anonymous, and now in the block type is the way how it's going to determine is the position as well as the sizing here. So a box type block, interesting, block, okay, the box type here. So the element is rendered in a box. It means that the block level element will take 100% of its parent container width, and the height will be the intrinsic, whatever or the content height. It's going to place elements from top to bottom, okay, and it participate in the block context formatting BCF. Holy moly! And not only that, we also talk about the anonymous box, what it is, and now that the way of how the browsers calculate is the position of all of these elements, okay, relevant to each other, especially the block elements, is by or how you even can calculate that is by even putting the content with the padding, the border, and the margin. So when you want to calculate is the dimension or the width of a block element, you can either is using the box side content box, which is something that we don't use because now, unlike box sizing border box, it's actually taking consideration is the content and the padding, okay, as the content width and then the margin. Let me take a quick break here. And we're back. Holy shit. And we are back. Okay. Alright. So now we understand is the mathematics behind the block elements and the other type of block, uh, which is mm, and the other type of block, which is the inline. Inline. Yay. What is this? Inline. That's right. And how now the inline element, which is a box type, here there are key characteristics of this. So they render as string flowing. Okay, they render as a string. So they render next to another from left to right and top to bottom, and they participate in the inline formatting context. They generate inline level boxes. So all of this, which is most of the time we use, is anchors, image, anchors, bottoms, image, site as well, inputs, objects, no, small, span, strong, time, tt, var, b, code, dfn. What the heck is dfn? I never use that. MDN. Okay. Why can copy this? That's interesting. But I think this is deprecated. No, it's there. Mm-hmm. All right. Okay. Interesting. BDO, big code, N, KeyBD. What in the F is KeyBD? KeyBD, MDN. Okay, you barely hear that. Mm-hmm. Give me this in English. Okay. Like Control Shift. Okay. Okay. KBD. Nesting. Mm-hmm. Mm-hmm. KBD. Mm-hmm. KBD. No, I wasn't familiar with that. Label map SAM. Okay, KBD. As a way to show them like this. Mm-hmm. Interesting. Mm-hmm. All right. Yeah. Okay. Very very specific. Is you build UI technologies or tech, web tech, you might quite familiar with this. Mm-hmm. You might quite familiar with this. But again, this is the inline element, the key characteristic of the inline element. You know, they represent or they render as a string or next one element after the another. Okay, and they participate into the inline formatting context. Again, this is the key characteristic of inline elements. They participate in an inline formatting context, and they generate inline level boxes. So this is now the mathematics of inline element. So this is how now these elements are calculated. So they don't. So inline element does not respond to width and height property. It completely ignores them. Interesting. Does not react to vertical margin. It ignores that. An inline padding in height, an inline padding does not alter the height of the inline element. So now we were talking is of the browser formatting context. So far we have talked about is a lot of the box model, the anatomy, the box, the property of the box, which is it is size and it is type, and how the box size actually contains is the intrinsic and restricted, which is determining it is size based on certain conditions, such as the pattern, the pattern percentage container width, or the pattern display type, whether it's a flex or grid layout system. If that contains children elements, and then I look at the mathematics of how you can calculate the width of the box, of the block box, as well as the inline box, the mathematics of calculating the inline box like this, and the key aspect of these inline elements. Width and heights are not applied, vertical line is ignored, and the an inline pattern does not affect is the height of the inline element, right? So with that, and what we also have is the things called inline context as well, which is the baseline, and if that pass through the baseline, now they are not take in consideration. This is known as the non-context height. So this is the intro or the input element in this particular case. So because we talk about and also that participate in the inline formatting context, because so far we have talked a lot of the context, okay, and what a context is and what it does and which is all of these kind of topics. So browser formatting context is establishing a set of rules of how these elements should behave. So this is in a realm where you have now different rules where now the elements that fall inside of this realm behave. Okay, so pretty much like in the Game of Thrones, in each particular kingdom, people behave in dress in a particular way, right? You have the people of Westeros, you have the people of King's Landing and the North. You know, each one of them dress and act according to their own realm. All right. Okay. Okay. Oh my god. Holy moly. So now this is the formatting context and keys ideas. So the key ideas of formatting context is that you have now isolation, scalability, and predictability. Wait, what? Okay, this actually moved. Yeah, this moved quite weirdly. But in any case, formatting context and key ideas. Okay, the key ideas of formatting context is that now they provide an isolation. So elements within a context are shielded from the rules of external context. Scalability because he's introduced a new rule of set, a new rule set for elements is as simple as creating a new context. Flexbox, yeah, completely. I agree with that. When you specify a particularly uh, when you specify how this uh, element will behave, or when you specify as a formatting context in these particular elements and all the children components, now it makes much more sense of how to create complex UI because now you have all of these well-defined rules that is going to apply then, which is part of the predictability. With a strict set of rules, the placement of elements is predictable. So yeah, I'm quite familiar with that. So you got flex, you have grid, inline, and block. Again, here we are mentioning is only the most relevant one because there's a lot of them. And it doesn't matter to mention, right? Okay, okay. So, okay, all right. Jesus, I didn't know anything, man. Jesus. Okay, so now let's get into this because I can record myself as and take because I can take notes, but don't I cannot record myself. Uh, actually, and I cannot. I already received a flag from the front-end master teams, especially the legal team, when they send me is a notice about, hey, you shouldn't do that. You're not allowed. You can learn from that, but you can record yourself learning and showing these kind of videos. So it's okay. It is okay. Um, so let's talk about is the browser formatting context.
So we mentioned element free, so the position of the element and the placement. So it's time to become a browser and try to render the following HTML page, going line by line and creating the formatting context like the browser does. So if we start.
Mm-hmm. Okay. Yeah, and this is now putting is, for example, all of these elements here. So this is now describing is example of browser formatting context. Example of browser formatting context. Example one, which is this. Oh my god. Okay. Example of browser formatting context. Okay. Examples of browser for formatting context. Okay. Okay. Example of browser formatting context. Where you get is this. Mm-hmm. which is okay, this is now block formatting context basic. Okay, and then you got now is the inline, which is that it's like inline formatting context, like so. And then you get the inline formatting context, like this. Exactly, inline formatting context, and now a mix of that. Which is a mix or mix formatting context. Okay, which is for example this one. Exactly, and with this couple examples here, all right, and with this couple example we also take a look at now how can we convert ourselves into our own but this is not an accurate, yeah, this is not quite accurate, which to me is quite sad, bro, which to me is quite sad, bro, because I don't want to get your errors. Yeah, because to me it's quite sad, bro. So this is block formatting context, like so. Yeah, the block formatting context, like so, like that. It's time to become the browser. Okay, time to become the browser. And that is, unfortunately, even though that you put that thing as it is, oh no, I would like to transform that into, transform this image to text, bro. Okay, so transform the following image into text or into code. Let me actually pass that content here. No, add a content here in our document. There you got it. All right. There you got it. Thanks for auto formatting that. That was lovely. And I want to transform it into a proper HTML, which is right below this one. There you got it. Okay, there you got it. Which is time to become the browser. I'm going to transform this. Wait, what? Okay. It's time to transform the browser, and this is now creating is the block formatting content as expected, right? So, because here the HTML is now a block. Yes, for example, block formatting context. Let me see if this actually shows something like this. Here, the root element of the document HTML create is a block formatting context. Okay, it creates a block formatting context, right? And then the body itself doesn't create anything per se, which is great, which to me is quite also interesting, is the HTML actually that create that blocking formatting content. It's a part of the visual CSS rendering of the web page. It is the region in which the layout of block boxes occur and which floats interact with other elements. So okay. So basically is that. So the body doesn't actually is creating any block formatting context. And however, these elements actually create is a block formatting context. The UL also create a block formatting context. The question is that how can we make sure that this is the proper element that actually are creating that? You know what I mean? You know what I mean? Exactly. It's because here this doesn't create any other elements. Remember that we are now is on the block formatting context, which is using the body here. The body doesn't add anything. The H1 in fact is part of its block, so it takes all the available space. The width 100% of the available space of its parent, which is in this case the body, and because the body doesn't have any constraint, so it will take now all the available space. The UI element here is gonna fit on the blocks browser context, okay, or the block formatting context, and now each one of these elements are creating is an inline block browser context or an inline block formatting context, making all of these elements is inline block, which means that you're creating here is a formatting context where you're gonna put all of these elements next to each other, similar to this, next to each other's, and then on this section, remember we still are on the block thanks to the HTML, we still are on the block context with block formatting context. We're here on this section, okay. Yeah, we're here on this section. We're here on this section. We are indicating to this element, hey, I want you to now behave in this way by creating is now this formatting context. And in this case, I think flex create also a block inline context. Flex items, if they are neither flex or grid nor table containers themselves. So it's like this. If they're neither containing each one of is each if neither of these elements actually is a flex grid or a table, of course it's going to follow now the block. In this case, it's going to follow is the formatting context of flex. Okay, the flex formatting content, where now here the paragraph is one of them, and this another paragraph is also, and inside of the P, whatever you define inside of this will follow is the default behavior, which is the inline or creating is this inline formatting context. So this is now how you make yourself familiar with this. And I think this is quite interesting as a way to move on to the next topics. As a way to move on to the next topic. And that is browser positioning.
Okay, so now we have the browser positioning system. So,
Okay. Okay. Now that we know how the browser create now that we know how the browser creates the formatting context, it is time to look at the positioning context.
in the web, we have a term normal flow. So it's basically when the elements are rendered in a natural order. So for instance, in the Altier languages, they rendered from top to bottom, from left to right. From RTL languages, they rendered from right to left. And if we have a term normal flow, does it mean that we can't remove elements from the normal flow? And apparently we can. So there is a special property called normal flow. So browser positioning system.
Exactly. This is browser positioning system. Browser positioning system.
So in the web, we have a term normal flow. So it's basically when the elements are rendered in a natural order. So for instance, in the Altier languages, they rendered from top to bottom, from left to right.
This is now describing is that how the browser positioning elements. Exactly. The normal flow makes sense. The browser positioning elements.
From RTL languages, they rendered from right to left. And if we have the term normal flow, does it mean that we can't remove elements from the normal flow? And apparently we can. So there is a special property called position that allows us to override how the browser position the
So position, what it's doing is to change the normal behavior. Or exactly, position, what it's doing is to change the normal behavior of the browser positioning system. Okay.
element. And the most used one is the static, relative, or absolute. So we'll start with the static. So the static is basically applied by default when you build your layout. The browser applies the static position to every element. And as you can see, if we render this HTML, we'll see that everything is rendered from top to bottom, from left to right. The position relative has a few interesting characteristics. So the element in the center is positioned relatively. So the key difference is the browser renders the element that is positioned relative the same as the normal flow, but the final position is determined by the top, right, bottom, and left properties in CSS. So we can move our element, and you can see when we move that, the change to the position doesn't impact other elements. So somehow we can adjust the position of the element without impacting other elements. And this is because the element is removed from normal flow. And when the element is removed from normal flow, it doesn't impact any other elements. And there is also one important term that we're going to look after a few slides, is a stacking context. So when we apply position relative, we create a new stacking context, some kind of new realm where we put
Exactly. So okay. So this makes a lot of sense. Okay. 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 So by default is position static, and then position relative. This is the element position according to the normal flow of the document. An offset applies relative to it is based on the value of the top right, bottom, and left. The offset does not affect the position of any other element. Thus, the space allocated for the element in the page layout remains the same if the position were static. The values creates a new stacking context when the value C index is not outer. Because again, uh, since okay, since the browser um, when we use position property, position CSS pro, okay, so since the browser, when we use the position CSS property like this, okay, since the browser, when we use the CSS property uh, position since we use position CSS property uh, relative value, it somehow allow us to not interfering with other elements, with other elements in the page. Okay. As long as the pattern is static or absolute. So the question is that how the browser knows how to position this element without breaking the layout.
All our elements, and these elements now are completely isolated from everything that is within the normal flow. So before we discuss the position absolute, I think it's important to understand the what is the containing block. So the containing block is kind of a reference point for the element, how it calculates its position on the screen.
Mm-hmm. Wait, what? But I got it, okay. Exactly, I got it there. Mm-hmm. Nope. Did you? What's wrong with you? That's not funny. That's definitely not funny. Okay. Okay, I need to guarantee that the server is here. Let's do it again. I'm not joking. Okay. Exactly. But the question is how the browser know how to position these elements without breaking the layout. The containing block is the element that allows to anchor or fix this. Div containing block of div rule if the element has position relative to its closest block level ancestor element in the containing block. And in this case, the rule, if the element has the position relative, it becomes a containing block. The containing block is the element that allow us to by using position relative to indicate, the containing block is the element that allows by using position relative to indicate what will be the containing block is the element that allows by using the position relatives what will be the elements I want you to use.
So for instance, for HTML, the containing block will be the browser viewport. When you open the page, you browse a window. So this is the default viewport for HTML. But there are rules when we can create the containing blocks. So for instance, if you apply the relative position to the div tag, you will see that because the relative position is applied, it becomes the containing block. So now the div is the containing block of the paragraph. So the same, there is one more rule, which is for if we set the position relative to the element, the closest containing block of this element will be the closest ancestor. So this means that the body as a closest ancestor becomes the containing block of the div tag. And let's discuss the position absolute now.
But the containing block is the element that allows by using the position relative anchor by using the position relative anchor an element so we can modify or let the browser figure it out the position of the element, or aka the stacking context.
So the position absolute behaves completely different from the relative positioning. So the element is removed from the normal flow. So if we apply the position relative or the absolute to the paragraph, so now we create a new stacking context. So as you can see, every modification that we potentially could do to this element will be isolated from the default stacking context. And also, the final position is always determined by the top, right, bottom, and the left properties. And absolute position item use it.
Using fag is this. It's because you're creating a reference point.
Its containing block to calculate its position. So by default, this element will be rendered at the left topmost corner of the element. And then we can adjust its position using the properties here. Let's try to render a few absolute items. So for instance, we have the following HTML. And right now we rendered the body, section, and a div. Now we have two absolute position boxes. So let's render it one by one. So when we render the box 1, so we created a new stacking context because position absolute is assigned. So when we render the second box, Then we created a new stacking context. So now box 1 and box 2 are rendered in a separate.
So in this case, as a way to actually look at the example here. So here we created a container. So container, I don't know what it is, but it's supposed to be use the block formatting context, and then inside of that you're gonna have a div, where this div is say, hey, now I'm going to alter the way how the browser identify me or locate me in the browser on the screen to relative. So I'm going now to be is this elements. I'm going now to create. So I'm now going to be the point of reference for all of the elements. I really love this. I'm going to be the point of reference from all of the other children elements, which means that all of these elements here that are on the box, they're going to now have a reference to myself, which is effectively creating an stacking context. Holy moly, bro. Holy moly, bro. Holy moly, bro. Okay. All right. Let's do this again. All right. Let's do this again. Let's do this again. With position relative, we are telling to the browser, hey, this element will be the reference. Okay. With position relative, we are telling the browser, hey, this element will be the reference of, this element will be the reference, will be the position reference, the position reference. This element will be the position reference, for all the child component. Okay, for all the child component, which means, hey, this element will be the position reference for all the child components, which means which now the browser creates a stack context.
Realms, and it also.
Okay, where now the browser create a stacking context.
So you can see that because it's a stacking context, the box 2 is rendered on the top of the box 1 because the layering works as like a stack by default, unless you apply the z-index property. So what is the key summary? Why it's important to understand the relative and absolute positioning as like a stack?
Exacto, ¿y esto en qué ayuda a los gloriosos leones del Caracas?
tagged by default, unless you apply the z-index property. So what is the key summary? Why it's important to understand the relative and absolute positioning? The benefit of the relative and absolute positioning lies in their ability to remove items from the normal flow. So if we use this positioning wise, we can achieve the isolation. So every modification to the element will be completely isolated. So it means that we can optimize the DOM performance. And it's also, we can minimize potential reflow. And we're going to discuss reflow just in a few slides.
Okay. So the reason of looking at this is the reason of remembering is the browser positioning is that, or this ability to remove element from the normal flow, is that if you use position wise, we can isolate that. Okay, we can isolate that element. All right. Okay, makes sense. And perform optimizations, and perform optimizations. Key prerequisite for optimizing and minimizing update to the DOM tree. So I started to see where you're heading, bro. I see where you're heading. So by doing that, so by looking at this, the browser positioning, and how anytime you use a position relative, you tell to the browser, hey, this will be the point of reference for all of the children elements, and therefore you're going to create is now a stacking context for each of these elements. So because the last child will be at the top and the most closest child to the parent elements will be at the bottom, unless you modify the z-index. This is the way of how now is stacking this. Stacking context. Why this is important? Because with this we can now isolate and realize and make performance optimization. Create prerequisite for optimizing and minimizing updates to the DOM tree.
And to prove the point that there is a kind of z-axis when we render the element. So when we just build a template with HTML, we usually utilize x and y axis. But there is another axis, which is z-axis, which is used when we apply some 3D transformation, absolute positioning. So basically when we work with the stacking context. And we will see later in a few slides how stacking context is connected to GPU and why and how the browser utilizes the layers. So right now, all we need to know that the stacking context provides us with a layering system and isolated realms of the elements. Okay, so
okay, and now again. Oh my god, I'm laughing because your exhalation, your breath, your breathe in, breathe out, your breathe out, your exhalation, is because there is a huge amount of things that you need to know. But what is relevant here is this. And I think this is the role of senior people, is that how you can make all of this abstraction, right, meaningful to others and relevant, my friend. Jesus doesn't have any place here because God won't save you. And because God won't save you. Oh, French toast now. Why is that? I know why he excellent. It's because there is a lot of things to do, and the real life, the reality needs you to be is on point. If you want to know more about this, alright, I can create a video, I can create a docu-series, blah blah blah. It's series on Netflix, Hulu, Amazon, Apple TV, whatever. So you can now click there, consume, and that'll be all. But oh my god. Oh my god, bro. Oh my freaking god, bro. Oh my French toast guy, bro.
later in a few slides how stacking context is connected to GPU and why and how the browser utilizes the layers. So right now, all we need to know that the stacking context provides us.
So when we build layouts, we work only with X and Y axis, meaning everything is placed on a single layer. However, when we engage in any 3D transformation, absolute position, or any action that move an element from the normal flow, we activate an additional axis known as the stacking context or Z-axis. That's quite interesting. That's why, for example, browser doesn't hang out when a lot of things going on. Useful when you want to create experience. Okay. Why does the browser need a stacking context? Layering. We need a way to represent layer in our layouts. Performance optimizations. Elements removed from the normal flows are placed into a new stacking context. Elements removed from the normal flow are placed into a stacking context. So now the browser say, anytime that I'm reading this HTML, and if any of these elements actually break the normal flow, I'm gonna put that elements into a layer. If you're using, for example, 3D transformation, it's with a stacking context. Absolute positioning and stacking context. Or any other element that removed an element out of the normal flow. Or any action that move an element from the normal flow. We are creating is a stacking context. Oh my god. Okay. So why does the browser need a stacking context? Because this is a way of how they can layering or how they can represent all of these layers. Okay, and for performance optimizations, elements removed from the normal flow are placed into a new stacking context, and modifications to every element within a separate stacking context does not impact any other element within the normal flow. Modification to every element within a separate stacking context. Wait, what? Modification to every element within a separate stacking context do not impact any other element within the normal flow. And all CSS transformations are GPU accelerated. So when you're creating this stacking context, especially these by using transformations, meaning that the browser doesn't need to recalculate the DOM tree when such operations are performed, and this minimizes the reflow cycle. God damn. Okay. All right. So everything is starting to make sense here. So my question is that how can I connect this? So this is a key summary, okay? And the other is that why we are looking at the stacking context, okay? But is that so? After we look at the browser positioning, okay, and now how you have is, holy moly. Holy moly. And now the browser position is how the browsers put elements inside of the viewport. Okay. So you have now the normal flow, which is the way how the browser actually is putting all of these elements. Okay. But you can change the normal flow by using as a position, which is you telling to the browser through CSS, hey, I want you to now make this particular element out of the normal flow. Put it out of the normal flow using is absolute, most likely. Okay, so normally your position is static on the entire browser. The other is a relative, which is act as an anchor to all the other elements that is be used, uh, yeah, that has been used as a way to now create is an stacking context, which is the way of how by you using or telling the browsers to break the normal or to move elements out of the normal flow with position absolute CSS transformations. You're telling to the browser create is a new stacking context. Unless you modify that stacking context with cIndex, it will do that for you, but it will create this stacking context. The idea of this stacking context is that now we have is this isolation or element position inside of this will not affect other elements within the normal flow. Makes sense. All right. And the other is performance optimizations, which is so far what I'm as far as I can see is that so the browser doesn't need to update the DOM, and then you can now focus on providing some more rich interactions. Then you have now this stacking context here, where is any time you want to uh, engage with a 3D transformation, absolute position, or any other actions that move the elements out of the normal flow, you are effectively creating is a stacking context or a Z axis. So why this is important? Why do we need this? Or the browser, why do we need this? Well, because layering is all of this HTML or all of this way to represent layer. It allows them to perform optimization on each one of those layers. Especially all CSS transformations are GPU accelerated, which means we can harness the power. So this is the way of how we talk to the browser that talk to the GPU. Hey, I would like you to now use is this computer, the GPU, the graphic unit, when it comes to do this. All right, it makes sense. It makes sense, and because now the vast majority of end device right now are actually have quite decent amount of GPU. Mm-hmm. So that's why we also have this kind of thing. Mm-hmm. So modifications to every element with a separate stacking context does not impact any other elements on the normal flow. Slowly but steady, starting to make
with a layering system and isolated realms of the elements. Okay, so to prove the point, we can render free boxes.
Mm-hmm. Position static, position relative, contain and block, position absolute, position absolute, position absolute, position absolute key summary, and then you got is this. That's a way to see now this. It's the viewport. Okay. And this is now the example of a stacking context 3D. Okay. Example static stacking context. And I think this is quite important, so you're gonna put this like so. Exactly. Exactly. If we take a look at now at this, what we're saying is that hey, box, and box. All right. Since after all, this is the viewport. and now we are using is C transformation. That's quite interesting. So what we're doing, but we're looking at this is that the container here, which is now behave as this formatting context, flex formatting context. Okay, so each of these elements here will behave like the flex formatting rules. This one followed by this one and this one. Okay, so it's going to now follow is the normal flow of this one element, and because I am assuming that they are now are out of the normal flow, when they say box display block, all right, so far so good. So this actually is creating is a block formatting context, another block formatting context, and another block formatting context. Okay, and when they have now red, yellow, and green, this is when you are actually is putting is a C index here with an animation. Of course, you're using is keyframe, which is perspective animation transform from C to 30-degree. Interesting. Can I change this? Huh? Come on, for real. What? Can I? Come on, man. Well, I guess. They say you want to okay. I want to rotate only any 3D accelerations are creating now that. So here you are now creating is a layer. Here you are creating is a layer and a layer and another layer, like so. When you're going to put this perspective, I think it is. Perspective animation is like this: C16, C32, and C48. Exactly, and I want you to transform them from 0 to 20 pixels. Okay, from 0 to 40 pixels, and from 0 to 96 pixels, and apply this animation from that, which is first perspective animation on the container. Okay, so when this content is loaded, I want you to apply this transformation, which is putting this element here, and then after that you're going to now apply is this transformation to all of this, and here they are synchronized all of this using the animation timer. But as you can see here, they now applying is this stacking layer here that actually it doesn't represent that, but it looks nice. It looks awesome. So when the component is mounted, now it apply a transformation and then this. That's quite brilliant, I must say.
And kind of and change the perspective how we view at the viewport, and then apply the translate Z and move the elements kind of on top of each other, so you see that they kind of stack on each other. Okay, so the next topic is reflow.
All right. So that'll be all for this video. Take care. Bye bye.